This is the help video for the Unit 5 study guide, the ALEKS portion. So the inverse operation of square rooting. Inverse means to undo is simply squaring. So when you square root of x, it becomes x. Keep that in mind. So your goal is to get x by itself right there. So in this case, you would do minus 12, and this would be negative 6 over here. So you would square both sides to get rid of that radical on the left. Negative 6 times negative 6 is 36 positive. And x equals 26. Now, many of you, you're going to like, wait, I got a whole number. It must be right. But wait, there's more. You actually have to test it. So we're going to take that answer and plug it in and see what happens. So we have square root 26 plus 10 plus 12 equals 6. This is our check. This is going to be 36 square root plus 12 equals 6. Square root of 36 is 6 plus 12 equals 6. 18 equals 6. You're like, wait a minute. That's not a true statement. Guess what? Then 26 is not the solution. So when you solve it and when you plug it in, if it doesn't work, you're going to be checking the box that says no solution. If you do plug it in and it does work, then you know it works. Down here, says right here that the length of the shadow of the building is 30. The distance from the top of the building to the length of the shadow is 37. Find the height of the building. And you know you have a right angle. So this is essentially leg squared plus leg squared equals hypo squared. Round your answer to the 10th place. So this is going to be x squared. I'm going to show you how to do it in one step on your calculator here. 30 squared equals 37 squared. Don't touch the calculator until x is by itself. So we can minus 30 squared. So you end up with x squared. 37 squared minus 30 squared. The opposite of squaring is square rooting. So we have x equals the square root of 37 squared minus 30 squared. Now, x is by itself. This is what you put in your calculator. If you have a TI-84, or better yet, you just use the ALEKS calculator because it'll work like that. So square root 37 squared minus 30 squared. And then you hit the equal sign. And you get 21.65. 21.65. So x equals approximately 21.65. Again, let me show you what that looked like in the calculator. Again, that was the square root of 37 squared minus 30 squared, 21.65. And it says round to the nearest 10th place, so you're going to round there. So it is approximately 21.7 units. Have two sides, need a third side, tag. All right, 30, 60, 90, short leg root 3, short leg times 2. Ready, nice and slow. 30, 60, 90, short leg root 3, short leg times 2. So this reads something times 2 is 8. And of course, that something is going to be 4. And then if you needed this side, you would times by root 3, so it's just 4 root 3. And you're done. 45, 45, 90. Leg, 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 root 2. 45, 45, 90. Leg, 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 root 2. This one reads a little bit different. So we have here something times root 2 equals 3. Looks a little strange. So you just kind of work backwards. I know for sure you need a root 2 there because that cancels the radical. You also need a 3 because there's a 3 over there. So we put a 3 there. Now see what you got. Root 2 times root 2 is 2. 3 times 2 is 6. We have to get back down to 3. So you simply divide by 2. So the correct answer here for C is 3 root 2 over 2. And this side would be the same. All right. For this problem, what you need to remember is this, that if the short side squared plus the medium side squared equals the longest side squared, its equals, then it is a right triangle. If the short side squared plus the medium side squared, if those two are greater than the longest side squared, then it is an acute triangle. If your short side squared plus your medium side squared is less than the longest side squared, then it is an obtuse triangle. Let's take a look here. Knowing this, 7 squared is 49, and 24 squared is 576, and if you add those two together, you get 625. 25 squared is also 625. So here's your short, medium, long. So we have this situation. The short squared plus the medium squared equals the long squared. That makes this a right triangle. 9 squared is 81. 10 squared is 100. So we got 181. 16 squared is 256. So we have this situation where the short squared and the medium squared is less than the longest side squared. Therefore, it is an obtuse triangle. Said in the right triangle, we want to find, has the lengths of 7, 24, 25. Find sine of y, tan of y, and cosine of y. Now this you don't even need a calculator for. In fact, there's fraction bars here. So I start with y because everything's made a reference to y here. From y, this is your opposite. This is your adjacent. This is your hypo. So sine is going to be opposite over hypo, which in this case, your opposite is 24 and your hypo is 25, and you're done. It just wants the ratio, which means it just wants the fraction. Tangent, it's opposite over adjacent. Opposite is 24. Your adjacent here is going to be 7. You're done. This one is adjacent ka, adjacent over hypo. And your adjacent here is 7, and your hypo is 25. And you're done. Taking a look here, it says solve for the triangle. Notice this is not 30, 60, 90, 45, 45, 90. You're going to be finding side links here. So now we're using SOHCAHTOA. So step 1 here, it's going to ask you for the measure of angle B, which is simply 90 minus 44, which is 46. So that'd be the first thing it'll ask you is whatever the last angle is. It'll use a capital letter. Now, since we started with the 44, and that's what's given, we're going to use that as our reference angle, even though we have the measure of this angle now, which is 46. And we're going to label A is going to be the opposite, B is the adjacent, and 30 is the hypo. So I'm going to solve for A over here, B over here. Have, need, do, have, need, do. For A, we have the hypo. We need the opposite. So we're going to do sine of theta over 1 equals opposite over hypo, which is sine of 44 degrees over 1 equals our opposite, which is the letter A, over the hypo, which is 30. Don't touch calculator until your variable's by itself. We cross multiply, and A equals sine of 44 times 30. And if you were to use an ALEKS calculator, it would look like this. All right, we do sine of 44, hit the equal sign, and then times 30 equals, and we get 20.839. Wants us to round to the nearest tenth, 20.839. So your A here is going to be 20.8. Coming over here to B, we have the hypo, and this we would need the adjacent for B. That would be cosine theta over 1 equals adjacent over hypo, and cosine 44 equals adjacent, which is B over hypo, which is 30. Cross multiply, and B is going to equal cosine 44 times 30. Cosine 44 times 30. So we come over here, and this is what the ALEKS calculator looks like. And we do cosine 44, hit the equal sign, times 30, hit the equal sign. We get 21.58. 21.58 equals B. Round to the tenths place. So it's 21.6 units. All right, taking a look here, we're solving for the angle this time. So we're using inverse SOHCAHTOA. We label still opposite, adjacent, hypo. We have here the opposite and the hypo. and we need angle theta. So what do we do here? We're going to use the OH inverse sign. So that is inverse sign parentheses, opposite over hypo equals theta. So inverse sign parentheses, your opposite here is 15 and your hypo is 17. That equals theta, and it says round your answer to the nearest degree. So this is what it would look like on the ALEKS calculator. Notice we're going to do inverse sine, parentheses, and it was 15 divided by 17. Notice the parentheses there, equals, oops, what's this? No double. Okay, inverse sine, and 15 divided by 17. There was a double parentheses there. Should just look, whoops, no, inverse sign. There we go again. 15 divided by 17. What am I doing here? Undo 17. There you go. Now it matches exactly the same. Enter. We want it to the nearest whole degree, and in this case, it'll be 62. So approximately 62 degrees. All right, so we have A and B. The sine of A is going to be opposite over hypo. So the sine of A, if we're to use this nomenclature, is going to be A over C. And the cosine of A is adjacent over hypo. Our adjacent is B over C. All right. Now it's going to switch it up. Now we're going to work with B. The sine of B, our opposite, is now the letter B, and our hypo is still C. And the cosine of B, our adjacent, is now A, the letter A, over C. Okay, take a very close look here. The sine of A is A over C, and the cosine of B is A over C. The sine of B is B over C, and the cosine of A is B over C. So there's a pattern there. And what we notice is the sine of one angle is the cosine of the other angle. All right, so let me write the two statements that are true. In this case, the sine of B equals cosine of A. That's one statement that's true. The other statement of true would be the sine of A equals the cosine of B. Those are both true statements. So you come here and you see which one is true. Cosine equals cosine, not true. Sine equals sine, not true. Sine of A equals cosine B. Oh, there it is. Check. That's true. Cosine A equals sine of B. Cosine A equals sine of B. Whoops, that's true. Check. That's also true. So the cosine of one angle equals the sine of the other angle. So if I have a triangle here, and I have 59 degrees here, the other angle, you simply do 90 minus 59. We get 31. So the cosine of 59 would be the same as the sine of the 31. The cosine of one angle is the same ratio as the sine of the other acute angle. So cosine of the one angle is equal to the sine of the other acute angle. And these two angles will always be complementary, which means they add up to 90 degrees. Last one. Taking a look here, let's color code everything. Mary sees two hot air balloons in the sky show. She determines that the lower balloon is 365 miles away at an angle of 23 degrees to the vertical. So when it says to the vertical, it means like to an imaginary vertical line. That's what from the vertical is. And the higher balloon is 1,035 meters away at an angle of 41 degrees. How much higher is the balloon on the right than on the left? So how much higher means we are ultimately finding this distance here between these two. And we're going to call that distance x. Now, it's really simple to find that distance x. If we find the green and we find the blue, to find distance x, you simply subtract. So our distance x is going to be that longer green distance, let me just color code that for you, minus that shorter blue distance. All right, so the green minus blue equals the distance x that we want. Now, very important, do not round intermediate computations. Round your final answer the nearest tenth. Let me show you what they mean by that. Let's go for the green first. The green, if I want the green from the 41, the green, this is adjacent and this is hypo. So to find the green, we would do this. The cosine of 41 would equal the green over a hypo, which is 1,035. Cross multiply, therefore our green is going to equal cosine 41 times 1,035. Keep that in mind. That's the green. If we were to do the blue is also adjacent. So the blue would be cosine of 23 over 1 equals the blue over 365, cross multiply. Therefore, the blue would equal cosine 23 times 365. That is the essence of the blue. Now notice it says do not round intermediate steps. So you have to put all of this in one calculator. Let me show you what this looks like. It's going to be the green minus the blue. So our green is cosine 41 times 1,035 minus the blue, which is cosine 23 times 365. Subtract that, and that would give you your x difference. So on the calculator, this is what it looks like. Notice you have to do this in one single step in your calculator. So it looks like this. cosine 41 times 1,035. So we have to use our brackets here. And we're going to do cosine 41, you do this, times 1,035, put brackets around that, minus brackets, cosine 23 times 365, cosine 23 times 365, put brackets, notice so that you take a close look at everything. Got it? And enter. Ta-da! And we 445.1. We want to round to the nearest tenth, so our x here, 445.1, check units, meters.